This evening, I'm going to talk about my invention. It's totally my invention and my group, totally biodegradable polymer called Sonali Bag from jute cellulose. So before going to lecture, why we start this biodegradable Sonali Bag and biodegradable biopolymers. So just I point out some pollution, plastic pollution is increasing in such a way, and this is a cartoon. Once maybe the plastic will catch us, maybe we can go through into the belly of the plastics. This is today actually I want to talk about the single-use plastics, not the whole plastics. And this single-use plastics is some points. Environmental impact. This is you can see the Great Pacific. There is an island which is in USA, and this is considered. So you can see how it is dangerous and making this island the plastics. As you know, the single plastics, its destination is the marine or in the sea. Because when we use in the plastic in our household or in our daily life, then it goes in the drainage to a river to ultimate destination is the sea. So that's why the problem is the marine problem. And application of plastic is sorry.
Excuse me, Minhaj, please unmute.
This is why this plastic is so popular because this is used in different sectors. So I'm giving a statistics. I'm not going in details. So this is the statistics and how is plastic use is going on. It's just it's called very straight line, so it is going up in the plastics. And when use the deposition is very high because this right side graph shows only disposable and this and recycling, and the most of the part remaining is sedimentation. So this is the plastic pollution increases, and we can see, oh my God. So it's maybe 2050, it's more than 10 times higher than that of this present situation. And this is the plastic pollution country basis. The China is #1, and Bangladesh is also not so behind. Here is the Bangladesh, is also here we are using. So there is a new statistics here. So every day, one Bangladeshi use 6 kilo plastics per day. We are using per head per day, 6 kilo. On the other hand, now US is the #1. US is using 63 kilos per day per head. So you can think about this, how plastic is usable. And there, I just point out there are some pollution, is water pollution, land pollution, and air pollution.
Dr. Khan, can you go to the presenter view, because we can see your left half. Can you go to the slideshow? On the top, you have the slide.
And now is okay?
Yeah, now it's fine. Yeah, perfect.
Okay. Sorry. And this is water pollution because when plastics or this polypropylene and polythene bag goes to the sea, that means saline water is degraded and it's converted very like to jellyfish, and all the marine animals, particularly tortoise, they think this is a jellyfish. They easily eat it and contaminate it. You can see some slides. So how it's contaminating this plastics in the marine animal. So this is a very latest. This is a shark, and it contains about 16 Mars. It is killed in. It was found in the Thailand, and we can found the 40 kilos of plastics bags in his belly. So it's a very recent data. So you can understand how plastic is polluted the marine animals. Then air pollution because of this incineration and this. So very recently you can see in the Damra or Dhaka, they are polluting methane gas is very, very high quantity. And it's very dangerous. The whole Bangladesh producing such a methane, and the same amount of methane is producing only in Damra. Have you been gone through this Damra this way? You can find there is a dumping zone where it's burning and methane gas is producing. So very, very dangerous. And there's a landfilling. You know, this landfilling also very dangerous, and this causes it needs very land area. And one thing is mentionable, that is single-use plastics means you use the plastics. This plastics is with you few minutes. When you throw into the earth keeps it thousands of years. So that's the problem. And this is the landfilling animal impact. It's a really, it's not joke. If you go for the your how to call it, I forgot this name of this, who's slaughtering the cow, and they're selling the meat, and you can ask this guy how many bags he found in the cow or in the bowl, in the belly. It's really. So these are some pictures, and this is a carbon emission. It's very dangerous. And after that, now the deep concern is microplastics. So when plastics break down, and the 5 millimeter, the length of the diameter is the plastics, that is it's called microplastics. And this microplastic primarily comes from the broken part of the plastics, originally plastics, and secondary it comes from the side reaction or the UV reaction, and we can find the microplastics. And that microplastics is a source of microplastics, as I said. So this is the life cycle of microplastics, how it's gone through. So this is plastics, and then it comes to biological systems and degradation in the soil. Then these trees also absorb the microplastic. These fish also taken the microplastic, and finally we took the microplastics. We eat the microplastic. And next slide, you can see there is some cycle. How can we eat? This is very dangerous. From the salt. This salt from the marine is contains about 1 to 0.1 to 0.2% microplastic in the salt. Then there is a cycle. We are eating microplastic every day, and there are so many data how many microplastics we are eating every day. 0.5 milligram to or more. We are eating microplastics from the food chain. These are microplastics effect of how affects our health and the lung and other places, and this is the skin diseases of the due to the microplastics. This is there's a really deep concern about the microplastics, and even though we eat the microplastic, we drink the microplastics through our water as well. Now I am coming to this bag. This is the, oh my God. I'm sorry, I maybe mistake some slides in another slide. Sorry. Can you change the slide? Hello? Can you hear me?
Yeah, I can hear you. You can change it. You can unshare first, and then you can make a new one.
Yes, that's right.
Yeah.
It's like the very
just unshare it, and then you open a new one.
Like before now. এটা কে তুমি? এখন তুমি ইয়ে করো। তোমার স্লাইড কোনটা বের করে নিবা না?
এইটা কোনটা দিছে জন্য এটা
ওকে বের করে লাগতে এটা নিচে এখন শেয়ার করব নিচে তো আচ্ছা
can you see these slides now?
Yeah, we can see.
Yes, we can see.
Yes. Actually, I made two slides. I'm sorry. This is kind of old guys, so the mistakes place. So that's not. Is it? Anyway.
That's okay. Go ahead.
Just. Okay. From here. So this is another concern at this moment is the nanoplastics, not only microplastics. This is also very dangerous in the nanoplastics. So even though microplastic, we can see the 5 millimeter diameter, but nanoplastics, 1 to 1,000 nanometer. It's very, very dangerous. So which we use in our drinks as well. So this is very, very deep concern about this nanoplastics impact in the environment. So these are the human health, how is affecting our different parts of the health and different animals in the forest and animals in the marine, as well as a human effect in every places, because it's a very dangerous in our lungs. It's asthma and other lipid profiles also increase in the gout and the intestine. There are some pictures of this. I'm not going on details in the microplastics. We have many lectures about the microplastics effects. So now I'm coming to my original lectures is a plastic bags fact. So every Worldwide, 1 trillion bags is used totally. And the total number of plastic bags used in every minute, one bag is used in every day. Every even number of years taken the plastic bags to degrade is more than 100 years, 1,000 years. And the total number of bags that were discarded, 3.5 million tons in 2008. And household waste, that the plastic is only 11% to use in the recycle. So these are the plastic pollution scenario in Bangladesh. You know, we every day we're seeing last Saturday, last Tuesday also, I had a I went to Matizil Ministry, the Secretariat. From Khilga, it takes 1.5 hours for because of water. Waterlogging is the main, the culprit of the plastic so far. I just mentioned. So this is, and there are so many effects of the single-use plastic shopping bags, but the problem is main problem is waterlogging in Dhaka city, mainly not Dhaka city, as well as the Chittagong city and other big cities. Even in Thailand, one day I was Thailand. I came to my flight was very early in the morning with my family members, but I cannot come to airport with the taxi cab. I have to hire a microbus, and even Thailand, Bangkok also the problem, same problem, and with this single-use plastic bag. So there are so many recycle opportunities to plastic bags. There's people are thinking to recycle, how to recycle and how to convert it in different areas or reduce these plastic bags. And mainly the people should take 8 ways to stop this, reduce the plastic bag pollution. People are educated and not to use this as a shopping bag. We can use the cloth bag, we can use other facilities. So these are the pollution, but problem, so it needs, we cannot stop, because this plastic bag is very, very important to us, as because it's very lightweight, it is very easy to carry, and it could be recycled again and again, whatever you want to make. That's why plastics is very important in everyday life. So people scientists are thinking about this many ways to reduce the plastics. Finally, plastic, nowadays, some scientists, they developed bioplastics. Bioplastics means the plastics made of bioplastics, the bags made of bioplastics. That bioplastics also contain plastics, and which is not totally degradable, and the residue also contain and converted to microplastic and nanoplastics, and that is very, very dangerous again. That's why, so we should to think about, if we want to reduce or not to use these plastic bags, we have to have made some alternatives. So in the meantime, so there are so many countries legislative against the plastic, ban the plastic, single-use plastics, and Bangladesh is the number one, and who banned the plastic bags in 2020 all over the world. And fortunately and unfortunately, I was in that meeting as a representative of Bangladesh Anti-Money Commission, and I raised my voice not to ban these plastic bags, though I am against plastics. because ever you cannot give any alternatives. You cannot keep your these legalistic rules, and you cannot. Even though nowadays, once 34 countries banned the plastic single-use bag. Even USA, China, and other countries, Belgium, United Kingdom, but they are not banned whole countries. Some regions, some states, they banned their plastic bag. But again, they have the problem because they don't have these suitable alternatives. Even though the bioplastic who claimed is biodegradable, the Montreal has also banned these biodegradable plastics because it is not compostable with the garbage. That's why they are also banned that bioplastics. The peoples now think about the Kenya is the very, very how to call this? They are keeping their rules strictly. Now they are using some bags made with the hemp fiber and some bamboo container, and they stop the single-use plastic bottle, water bottle. They are using again glass bottle. So these are some techniques how to reduce this plastics bag. But better you have to think. There are so many ways the conventional plastic waste management, this landfilling, and in USA they have many vast areas land, unused lands. They could use that land for this landfilling. But if you think about the Europe is a very small. Every country is they don't have any space for the landfilling. They are really a problem. Once China buy these waste plastics from those countries, but now from the last year, China stopped buying their waste plastic from different countries, even though Australia as well. That's why the landfilling is not clear. I showed before slide. Some slides is also dangerous. And the next is incineration. Incineration has very, very dangerous. Though people are doing in Bangladesh, there are some people they are doing some plastic they're putting in some container and they got some petrol. And they say, oh, it's a very good, but this is actually very, very hazardous. They are producing some chemicals and the carbon monoxide, which is very, very, even they're not sorting out the plastics. They're using PVC, they are using PP, they are using polyester. So this is not good. So incineration is not the good method for the plastic recycle. And recycling is also, nowadays recycling is one of the most effective method. And in the market, you can see some color bag, plastic polypropylene polythene bag. That is the recycle bag. If it is virgin bag, that should be very clean and white bag. But when you see this bag is colored, then you certainly this bag is a recycle bag, because the polypropylene polythene when you recycle, it's the browning color is yellowish color is generated, and the properties also degraded. And during these recycle procedures is produce carbon dioxide, and this is also very dangerous. Now I come to my point. So I said the Sonali bag, the biopolymer. So biopolymer defines is which originated from the bioorigin. That means cellulose, starch, proteins. These are the biopolymers. And these biopolymers, when we converted it into the polymers, this is biopolymer, we can say. But this biopolymer, when we use this biopolymer with the traditional petroleum-based
I think the connection is lost. Dr. Khan, we cannot hear you.
Or some polylactic acids, and they are using PBAT, polybutyl acrylate, and this is a synthetic polymer because they are processing this. Now UN, they stop this bag because they are using starch is a food item. They said you cannot use food for producing the shopping bag. So again, this is a problem. So next, so what is the biopolymer? The second highest production is cellulose. So this is the way forward, how we can solve this problem. So this is the your polypropylene bag and finally is banded, but the next one is the cellulose to Sonali bag, and we can use this 3R system and we recover the bag without polluting our environment. As I said, the bioplastics also biodegradable. It's not biodegradable totally. It comes from fossil fuel and derived plastics. So this is, now I come to my point. This is the flow chart of the Sonali bag production. So we just use the jute and we cut the jute and we produce the cellulose. And then this cellulose is converted into water soluble cellulose. And this water soluble cellulose, we produce the film like this. And finally, we produce this bag. It's called Sonali bag. So I just mentioned the name of the Sonali bag is given by our Honorable Prime Minister. It comes from Sonali fibers, that is golden fiber, and she made this and she named this bag is Sonali bag. So this is starch derivatives, biodegradable bags, and cellulose derivatives, biodegradable bag. So this is cellulose is always stronger than the starch. Though there are some Professor Zeba and others, those who are the biochemist, and they knows how this difference in the cellulose and starch. Starch we can eat and we can digest, but cellulose we cannot digest. But on the other hand, the animal, they can eat the starch and cellulose, both they can digest because they have this special enzyme, but we don't have this special. They're the same structure, only linkage, alpha linkage and beta linkage is the difference. So in this difference, we thought, if we can, the people can make this polymer from starch, why not cellulose? Then we start actually our research and we start reading the chemistry, how to convert this cellulose into the alpha linkage to beta linkage. So that was our first challenges. And finally, we could make and we could polymerize this cellulose without using any synthetic polymer. So this is the common picture, some pictures. Now how we can make the cellulose at this moment. As you know, there is a small pilot plant production in Loti Boni Jute Mill in Damra under the Ministry of Jute, Textile and Jutes, and they are financing for this project and government financing this project. And we are making Sonali bag at this moment, 1 ton Sonali bag sheet polymer, but we cannot prepare the 1 ton equivalent to 1 lakh Sonali bag. But now we don't have these machineries, automated machines, the making this bag, but we can produce the quantum small. So this is the first step. So we cut the jute. We can extract the cellulose for cellulose extraction, but we developed a very, very new method, cost effective and environment friendly, one-step method. Just one-step method, we can extract the cellulose from the jute. Sorry. That is another first time, you know, this cellulose generally extracted by pulping method with using carbon disulfide or NAMO. They are using both are NAMO is very expensive and carbon disulfide is very hazardous. But we are not using any of these chemicals. We are using very simple chemicals. And this, then we converted this machine. Is one thing I have to mention. All our machines, these are machines developed in our laboratory using our own idea. So we are going to Novapur, we are using some parts, we are using this, and we developed ourselves this whole machine. Still we are not buying or you are not imported any machine from other side. So you can see this, the plant where is making this solution and feeding machine, and that solution comes automatically to this film casting machine and produce the film directly. This part is totally automatic. These are this flow chart also this, but it's now this machine we brought from the printing machine. This printing machine is 6-color printing machine, so we can print this machine. But here you see this, we are making bag by hand manually. We don't yet buy the automated machine. The problem is this is not sealable because it is a cellulose based, like your cotton, your shirt or a pant. So it is not heat. It could not be. It could not make the heat sealable. So we are making gluing system or cost-step system or making this bag. But very recently we contacted with the Chinese, Japanese, and the German as well. We are using, and now we are sealing the ultrasound techniques. We are using gluing system. We are using other extract some another method. The Chinese develop these things, but still then they need some extra money for R&D in advance. You know, this is the problem. The government cannot give the extra money advance. That is something different from the private sector and the government sector. This kind of is still very challenging for sealing this machine. But other things okay. Significant back. It's a totally biodegradable biopolymer made of cellulose. We are not using any plastic. So it is totally biodegradable, compostable water. It is a time dependable biodegradable. This is very important properties of this Sonali bag, because so if you want, you can immediately you can dissolve in the water. Or if you want, you can keep it in our for 6 months in the water. We can make that samples. So this is very important factors, and that's why we call it a sustainable. And another claim is that the environmental friendly. This environmental friendly, nobody can declare the samples are environmental friendly, because the environment of USA or environment of Russia is not same as the environment of Saudi Arabia. So there is some weathering condition. So we have to develop. It's a sort. One day I went to Iran for giving a seminar, and we took some back. I reached there at midnight, and the room was heater is on. And when I opened this Sonali bag, I just see this bag is going to crispy. So it's just like, and I thought, what happened? Why this is like this? But when I came out from the hotel room, then it is again normal. That means the water permeability and the moisture uptake is very, very effective in the Sonali bag. But now we develop these properties, we change these properties. So that's again another, just I give it because this is the Professor Zeba said প্রচুর পাতা যেটা আমরা বাংলায় বলি আর কি. When you drop the water on the aroma leaf, just go out, not to in each side. So this is my mind, like this leaf. So should think about from the nature. Always the scientist can think about the nature, and he can learn from the nature. So this is environmentally the tensile strength is 1.6 times higher than that of polypropylene. It's if you can take 10 kilo materials in the polypropylene bag, and in the same size bag you can take 16 kilos. So it's another good properties. The raw materials and the process is renewable, and the process is also environmentally, because it is circular economy. We cannot pass a single drop of water in the outside, and whole things we can recycle. So simple process, very simple process preparation. Production process is also very important. So why jute? So there are every plants contain cellulose, but why you took the jute? You know, jute contains 70% on average, 70% cellulose, hemicellulose 2%, lignin 10%. This harvesting time is 100 to 100 days. Wood contains 30% cellulose, but it takes 15 years. It's a maturity. So you cannot find any tree plant like jute which contain 70% jute, and when it is almost 100 days. This is very, very, very important crops in Bangladesh. But if you think about the jute plant, it's a 1 hectare jute plant, it absorbs million tons of carbon dioxide. But when you produce one polypropylene, it produces several tons of or million tons of carbon dioxide. So you think about this carbon emission and the environmental conservation, carbon footprint, jute is the #1 player. So if we grow more jute in Bangladesh, and we can reduce the carbon emission, at the same time we can find more cellulose as well. So these are some properties we studied in our. So this is a contact angle. We use the scientifically data how much water can absorb. This is immediately water soluble, and you can see how it dissolves. But on the other hand, you can see we are keeping the water in the bag, and we can keep it some days in the same. It looks like same, but the property is different. These are the biodegradable soil degradation. And after 30 days, after 90 days, after 20 days, we cannot find. And then we can put or mix with the water, the soil, it produce fertilizer. Because it is simply cellulose, that's why no harmful things is generated. And this water also we tested. When dissolved this Sonali Bag in the water, we also tested the FTIR, and there are so many methods. We could not find any dangerous or any harmful materials in the water. Even though we are studied the heavy metal, is there any heavy metal in these products? We could not find any heavy metal in this product. 76 elements we did it. And these are the images, microscopic image. And for this optical microscope, we can see these are the cellulose. In general, in looking, we cannot see anything, but when we see the microscope, and these are this jute is remaining inside, we can see this optical microscope, and we can measure the diameter, we can measure the length, and these are the atomic microscope, this scanning electron microscope, this transmission electron microscope came. So all rebels also proves that this it's remain cellulose, nothing else inside. So when you burn, this is the most important things. When you burn, Sonali Bag produces ash, just like a paper. But when you burn this polypropylene, it's produces the petrol, drop voice. And you can ion it because it is not heat soluble. So the bag, we can ion it. So these are the some machinist data, and the transparency is also the same like polypropylene and polyethylene. Even though we can use the color bag, this color we are using the color. This color is also vegetable color. We are not using any synthetic color. All are vegetable color. We're using, so everything is natural. So this is sustainable goal, you know. So we are hitting several SDG 3, SDG 6, SDG 11, SDG 12, SDG 13, SDG 14. So these are the we can hit this Sonali Bag, and this is the main challenges of Bangladesh. So
Dr. Khan, we lost you.
in your house,
okay.
Just you can buy, you can burn this Sonali Bag, it produces ash, and this so-called biodegradable bag, when you burn, you can see the plastics remaining is drop voice, is petrol is dropping. So this is the only single test you can see whether it is plastic bag or whether it is natural bag. Eyewitness in
Yeah, the connection is very poor. We are losing Dr. Khan. Can't hear you.
Then we started to thinking, even these hand wash with sanitizer.
So it looks like we lost. Okay, it's back again.
So,
now we can hear me.
Yes, now we can hear you.
Hello.
Yeah, we can hear you.
You can see the slide. Okay.
Yes, we can
so
see.
This is the okay, thank you. So this is the PPE. So about 100 million tons per day extra PPE and masks are generating during this pandemic situation. So then we started this project personally and studied, and the Sonali Bag, Sonali sheet along with the chitosan solution, irradiated chitosan, low molecular chitosan, oligochitosan. We mixed it and proved. Then I talked with the higher authority of Bangladesh, IDCR and the Jute and the Jute Minister, but nobody can believe it. And then I tried to send it to MIT Solver, my concept, and they believe it. And I give it the mechanism, how it works, and giving us some video, slideshow. Then I send this PP to them. They prove it. Finally, I
Yeah, again we lost.
a lot of. Now we are waiting. Consortium will give the license. This is medicated PP, so that doctors, nurse, even though ourselves we can use this PP. Beforehand, we send this PP to the Japan. They are use this PP before pandemic. They use in the hospital. You know, when we want to enter into the ICU or CCU, then we need to a ground, and that is made of polyester. So we can use easily this, and there is no cost for disposable. So main important things, this is biodegradable. When you use and put in a bucket which contain water, soapy water, which pH is around 12, that within 3 minutes it dissolves. So, and all these pandemic, the coronavirus will die with how few minutes, because it is pH sensitive. So these are the techniques. So, but we cannot go for commercialization. And another thing is clear mask. But I'm preparing this clear mask and transparent mask, but it is so important. I don't know. Now USA, NHI, National Institute of Health and USA, they ask me, can you make a prepare this clear mask with your PP? Then said yes. And I sent this PP to NIH, National Health Institute USA. Now they are testing. And one people came to Bangladesh and they saw my techniques. This is going to be, and this is still under certification, but it could be used. But it is still some challenges, the porosity. And the coronavirus, the porosity, the diameter of coronavirus is very different, single digits to double digits, digit. So it is sometimes different. And these are the, and third things we already commercialize, not commercialize, we already, the sanitary napkin for women or girl, the sanitary napkin, you know, this is solid waste. And we prepare this sanitary napkin using this biopolymer, and we made super absorbent sap, which could be absorbed 20,000%. That means its absorbance is so high, and the thickness of this sanitary napkin is 1 millimeter to 2 millimeter, and the length is 3 inches and weight is 1.5 inches. And this is so light that nobody, this woman cannot understand, is there any foreign bodies with them? And another important thing is the flashable. Just change it and put in the toilet and flash it, and it's totally biodegradable and goes to the water. And same condition, same technique, now we're going to make the diaper for their children, or diaper, you know, this use all this, even old man also now using the diaper. Now it's expensive, very expensive diaper, but our diaper is very cheap, lightweight, easy to wear. So these are the products we are still using. And this sanitary napkin is under the project of Islamic Development Bank project with the collaboration of ICD-DRB, the 2 doctors with me, and they are already first trial 10 doctors, they trial first it, then 20 slum. Now we are trial 50 slum people along with 10 educated people because of the size. Now which size is more comfortable? So then we finalize this product, and maybe we can go for commercialization for this sanitary napkin. And this is a conclusion. I already said it. So this is Sonali Bag. And lastly, I want to show you a video. If you have time, you can see the video. Can you see the video? Hello?
Yes, sir.
Plastic has become an integral part of our daily life.
This is a professional video of my Sonali.
Plastic is not biodegradable. According to estimates, from 1950 to 2018, approximately 6.3 billion tons of plastic has been produced worldwide. And currently, 380 metric tons of plastic is being produced each year. Plastic, combined with the industrial, agricultural, and urban waste pollution fueling the algae explosion, causes oxygen deficiency, resulting in the death of marine life. With sustained pollution, this created dead zones which exist from 400 locations around the world. Waterlogging is a severe problem in Thailand, the capital city of Bangladesh. In monsoons, it faces waterlogging in medium rainfall, and the situation goes beyond control. In the case of heavy rainfall, it drowns the city underwater for days. The only catalyst for the situation is polythene, which blocks the drainage system for years as it is not naturally degradable. In fact, the severity led the government to formulate the Environment Conservation Act in 1995. Later on, one of the sections was revised in this act, strictly banning the production and use of 20-micron thick polyethylene shopping bags from January 1st, 2002. Despite this, the use of polythene continued illegally because of the unavailability of a sustainable alternative. Surely, banning without ensuring a sustainable alternative cannot be a solution. To address this problem, a Bangladeshi scientist is looking for a unique, environmentally friendly solution. Thus, Dr. Mubarak Ahmad Khan came up with a unique innovation with his 18 years of extensive research, Sonali Bag, poly bag made from jute, which is completely biodegradable.
So we can use this jute as a whole, but presently we are using the jute dust, which is mill waste, you can say. So this jute dust is collected and we can bleach it, and then we dry the jute dust, and this dry jute dust we can prepare the cellulose. This is cellulose, so we can wash it in running water. Is the important factors. We have to neutralize the cellulose, so no more alkali inside this cellulose. It should be pH 7. Then we prepare just water soluble cellulose. It's mixed with another binders and some other cross linkers and chemicals additives, and then we put it into the reaction tank. In this reaction tank, we can maintain the temperature and pressure to complete the whole reaction. And after that, this solution is collected and put onto the conveyor belt of dryer. This dryer, we can use the thickness gauge. We can control the thickness of the belt, and after drying, we can prepare the belt. We can control the thickness as well as we can control the polyethylene density, which is actually depends on the time degradable product. The product is environment friendly as well as the process is also environment friendly. Jute is abundant in Bangladesh, this one factor. Second is the jute contains the highest number of cellulose. This is around 65 to 70% cellulose content, and never you can find any plant those who contain this such amount of cellulose. From the day one, from the cultivation, it takes only 90 days or 90 or 100 days. On the other hand, from the tree, you get only 32% cellulose, but it takes around 15 years to mature the tree. This is the beauty of jute.
Jute, the magical plant, is capable of absorbing carbon dioxide on a greater scale compared to other plants. Moreover, this wonder plant directly meets the 11th, 12th, 13th, 14th, and 15th targets of Sustainable Development Goals. The Honorable Prime Minister of Bangladesh, Sheikh Hasina, visited the Sonali Bag stall on March 6, 2019 at the National Jute Day. She acknowledged commercializing the biodegradable and eco-friendly invention as early as possible. In response, Dr. Khan, along with his technical team, made a one-ton capacity foam casting machine, which will start production very soon. Jute, the magical plant, being the solution for the plastic pollution and biodiversity problems, still faces some obstacles. If the new polymer or other next-generation products are considered for global well-being, current production of jute is not enough. Having the help of nature by harvesting the crop, and again, returning the processed product to nature without any harm to it, rather keeping it safe. We only have one planet to live on, and we must take care of it.
Thank you very much.